is to inform the community about the current status of the development of Arrowhead 5, what to expect in general, and I also would like to highlight some of the new features that are hopefully will be beneficial in most of the in the use cases. So we have a development roadmap, which is public, and you can find it in the Eclipse Arrowhead GitHub organization and under the roadmap repository. You can use this link on the slide to find it easily. I will send out these slides after the meeting to the same mailing list where the invitation was also sent to. So you all will have it. And it is the most important that the planned release date of version 5.0 is 31st of July. It will definitely contain the 4 core systems, the service registry, a service orchestration core system which supports the dynamic orchestration strategy. It will contain also the consumer authorization and the authentication core system, which is a completely new component. We haven't have such in the previous versions. I will get back to this a bit later. And it also will contain a support system, which is the blacklist. This is also a completely new stuff, and as its name says, with this support system, you can completely exclude certain application systems from the wall of your local cloud. Although the official release with 100% unit tests and documentation coverage will be at end of July, test builds are already published and still will be published in the coming weeks. These test builds are functionally finished system. People can try them, and we of course encourage everyone to test them and report the possible issues, if any, to the development team. But you should also know that minor or slightly major changes still can happen until we reach the final release date. Later I will show where you can download these test builds. Still in this year, at the beginning of September, we plan to have the 5.0 release, where the translation manager support system will be the addition. And in the middle of the November, we plan to release the version 5.2, where the new quality of service support will be released. One important note regarding the coming releases, that since this is a completely new generation with a lot of fundamental changes, we plan to publish also a migration guideline how you should migrate your application system from Arrowhead version 5 to Arrowhead version 4 to Arrowhead version 5. We plan to have this guideline at least ready to review within July, end of July. So this is our roadmap. This is what we try to keep. And I would like to continue my presentation. The features what version 5 will offer you. So we have really a lot of changes compared to version 4. And one of the main focus what we had during the specification phase is that Arrowhead 5 should be much more flexible. And a couple of things that targets this goal is listed here. For example, the individual and cooperative working modes. You can deploy different working modes for different use cases. We used to say that you can deploy your use case-driven local clouds. One is when your Arrowhead components, the core system, are working individually and not cooperating with each other. So your application systems should be more autonomous and should have more responsibilities. Sometimes this is the required way of behaving. And the other type of working, which we call the cooperative working mode, when your application system could focus only to performing its microservices and let Arrowhead framework manage all the necessary tasks and responsibilities as much as possible. So the authentication, authorization, if authorization token is required by the provider, then it will be generated during the orchestration process, and your consumer should not to take care with it. I will detail it later on. We will, or version 5 will offer you various ways of system authentication possibilities. In version 5, so version 5 will offer you more way of system authentication, because in version 4 we have only one possibility, which was based on the X509 certificates, but now we extended the possibilities in the coming version. We also have multiple ways to deal with the service consumption, authorization of the service consumption. So instead of having peer-to-peer authorization rules, now we will have policy-based authorization rules between the consumers and providers, and of course the services. And we have multiple types of authorization tokens what your provider can choose from. And beside the various orchestration strategies what we already have in version 4, now we will present also two types of orchestration types, which was existing in theory, but it was never implemented. I mean, this is the pull or push orchestration. I will detail it also. And I said our main goal with generation 5 also is to provide an advanced translation support to the users of Arrowhead framework, and it will so with this help of translation support, you will be able to use communication protocol translation between the consumer and the providers, but also you will be able to translate the payload from a specific format to another format, and you can translate it also the data formats, but also the data models. And of course, our overall goal is to provide a higher level user support. That's why we have this global system of system description. This is a very important document which describes the higher level architecture of an Arrowhead local cloud. What are the possibilities, how the core and support system can cooperate if this is the required. So what are the recommended naming conventions and so on. And we are also developing a dedicated documentation site for the reference implementation. This is the place where you will find all the API descriptions, the tutorials, the system and service descriptions, informations about how to configure the specific core systems and so on. So let's detail all these things. So this figure shows you an example about the individual working modes I just mentioned before. So let's have an example with an Arrowhead local cloud where you have a service registry, a service orchestration, and the consumer authorization core component deployed, but these are not cooperating with each other. So your consumer, if wants to find a matching provider, wants to orchestrate for a matching provider, it will turn to the orchestration with the request of its orchestration request. What is the service he wants to consume? And the orchestration result, what the service orchestration will proceed, will contain only for a service identifier, and will not contain details about the service access or what are the service security level which is required by the provider. It's just a service identifier. And using this service identifier, your consumer should turn to the service registry and consume the service discovery service and the lookup operation in order to find out all the service details, which is the access address, which is the security level, which is the interface, possible interfaces provided by that provider. And if your consumers gather all this information, then it can, and if the provider requires, for example, token level authorization, then your consumer should deal with also the consumer authorization core system in order to get the authorization tokens. And it will consume the authorization token generate operation. And after the consumers have these tokens, then it can turn to the matching provider and send its service request with the service with the authorization token. So everything is managed by the consumer. And in the other working mode, which is the cooperative working mode, which has the purpose for the consumer that it can focus only to, So it has the purpose that your provider and consumer should focus only to consume and providing the microservice, and every other detail should be managed by the Arrowhead framework. So let's have the same example. Our consumer wants to find a matching provider, and we have a local cloud with service orchestration, service registry, and the consumer authorization. But in this case, your consumer turns only to the service orchestration core system, sends its orchestration request, and the service orchestration will be the actor who will collect all the service details from the service registry. It will check the authorization rules and generate the authorization tokens with the consumer authorization core system. And after everything is ready, it will send back the orchestration results to the consumer, and it will contain all the authorization tokens, and it will contain only those providers who are authorized to consume for the specific consumer, and your consumer have only to choose the right provider from the list and use the tokens to start its service consumption. So everything is managed by the framework. In version 5, 3 authentication policy will be offered. So as I was mentioned, in version 4, all the authentication was relied on the Arrowhead certificates, the X509 certificates. But in the coming version, we will expand the possibilities, and 3 way of authentication policy will be offered. One is we called the declared authentication policy. In this case, the core and support systems simply just accept the identity provided by the application system. So no real authentication is happening. This is not recommended to use in production environment. This is recommended to use only in testing cases. We kept, of course, the certificate authentication possibility so this requires client-side system profile certificate being provided by the application systems. The issuer and the identity-related content of the certificate are always verified when a consumer or a provider turns to the core systems. The only changes made in the certificate authentication is that the certificate profiles changed a bit because in version 4 we have a 4-level certificate profile, and now in version 4 we have a 3-level certificate profile, but now we will have a 4-level certificate profile. It means that the cloud operator and the cloud itself has different certificates as well, and in version 5, but in version 4 they have one certificate which was valid for the cloud and operator altogether, but now it's divided too. And the third authentication policy, what the coming version will offer, is the outsourced policy. This requires a specific service, the identity service, being provided by a core or a support system within local cloud. And this system can be the dedicated, officially dedicated system, which is the authentication core system, who provides this identity service, or it can be any third-party solution that implements this service. And you can hide your own authentication methods always under the same the same identity service. So the inputs are always the same format. The service inputs are always in the same format. It is designed the way that you can have any kind of credential data in this input data, but the outcome of this identity service is always an identity token. So no matter what happens with the credential, what was provided by the consumer or the provider, the outcome of the authentication procedure is always an identity token. And the official authentication core system will perform the authentication process based on system name and the password. But of course, if you need something more, then you can implement this service that the input should contain, I don't know, a shared secret, or you can hide your OAuth or keycloak solution under this service. All right. So let's see how our example changes when we have also an authentication core system deployed into our Arrowhead local cloud. First, let's have the same example we had before with the individual working modes. So as you can see in the picture, every time when you're everything begins when the consumer log in with the authentication core system by consuming the identity service and the login operation. It sends its credential to the authentication system and gets back an identity token. And every time when your consumer turns to a core system, first to the orchestrator, service orchestration core system, it should send also this identity token to the service orchestration system beside its orchestration request, and this token will be verified by the service orchestration core system and with the authentication core system. Sorry. And the same will happen again when your consumer will turn to the service registry and tries to look up the service access details, and also when your consumer will tries to get tokens for the service on consumption. So every time a consumer or a provider interacts with a core component, this identity token will be verified with the same authentication core system. The same happens in the cooperative working modes. The only thing that since the consumer turns only to the service orchestrator, only the service orchestrator will verify its identity token with the authentication core system. An important note that these identity token should never be shared with the application system, with other application system, I mean with consumer or provider. This identity token should be shared only with the trusted core components, so the core and support system, in order to prevent any kind of identity theft. How the provider will be sure that the consumer is part of the same local cloud, since the provider cannot check its identity, it will be guaranteed by the authorization process and authorization tokens. I will detail also in the coming slides. All right, what are the changes in the authorization procedures? So first of all, in version 4, only the operators with management permissions will be was able to create authorization rules for the consumers and providers. Now in version 5, the providers will be able to define their own rules as well. But if there is any management level authorization rule for that specific consumer or provider, then it will have always priority. Yeah. And in version 4, we have only peer-to-peer authorization rules, so you can express only that this specific consumer is authorized to consume this specific service definition from that specific provider. Now we change to policy-based authorization rules, and you will be able to express that the service or service operation is accessible anyone within the local cloud, or anyone within the local cloud except these consumers. So you can have a blacklist. You will be able to express that this service operation is accessible anyone from the given list, so you can use a whitelist as well. And you can express also that this service operation is accessible anyone within the local cloud who is having the specified metadata. So you can describe a group of systems using metadata, and if it's matching, then it is matching to the rules as well. On the provider side, the provider can require or can choose between 3 different security levels. First, they can say that there is no security check on my side, so no verification happens on the provider side when the consumer attempts to consume its service. And we have also the certificate security level, when the consumer have to send to the provider also its certificate. So the provider will be able to verify that the consumer is part of the same local cloud or not. And we have also the token based security level. So these are expirable tokens. The provider verifies that the consumer has proper permission to consume its service operation at the moment of the consumption attempt. This is almost the same what we have in version 4. The big change in here that we are offering more type of authorization token. In version 4, we have only one type of authorization token, which was a JSON web token. Now we are offering more simple possibilities and more difficult possibilities as well. So there is a simple time-limited token, what a provider can require from the consumer. These tokens expires within a given time, of course, and the provider has to verify it with the consumer authorization core system. So practically, the provider will receive only a string token. This string token should be sent to the consumer authorization core system, and it will respond back that, okay, this token is still valid or not, and who is the consumer, which is the consumer's cloud, what was the service definition and operation that this token was made for, and the provider can use this method to check these time-limited tokens before it would proceed its service logic and response to the consumer. We have a very similar one, a simple usage limit token. The token expires after a certain number of uses, and again, the provider has to verify it with the consumer authorization core system. And we have a different type of tokens, which are the self-contained token. And in self-contained tokens, we also have two subtypes, so to say. So the self-contained token is also expires within a given time. It always has a payload which contains the consumer, provider, the cloud, the service, the operation, and the expire time. And the provider has to verify by itself. So your provider not consulting with the consumer authorization core system when it gets a self-contained token, but your provider deals with it by itself. And we have a base 64 type of self-contained token. This means that all the content, the payload, is encoded with the method of base 64. And when your provider receives it, they can encode it and read the payload. Since the payload can contain sensitive data, there is a possibility to have this token encrypted. So your provider can register an encryption key into the authorization, into the consumer authorization core system. And every time when a token is generated for the same provider, the token itself will be encrypted with the encryption key what was provided by the provider. And also we have the JSON web token as a self-contained token, very similar with than the base 64 type of tokens. The only difference between them that this JSON web token can be signed by the consumer authorization core system. It means that to use this token, the core systems should have SSL certificates, and if the token is signed by the consumer authorization core system, your provider can be sure that this token was generated by the core system, which is belonging to the same local cloud as the provider belongs. So this is the most secured token type of authorization what version 5 will offer you. Of course, it means if a provider wants to use this self-contained JSON Web Token, that it should fetch the public key of the consumer authorization core system, because it will be necessary to verify the signature of the consumer authorization system on the token, of course. Let's continue with the service orchestrations. So there are 3 orchestration strategy, the same way as we have it in version 4. The difference that it is divided into the 3 different systems. So we have again the simple store orchestration strategy. This is the strategy where you can define peer-to-peer rules, and during the orchestration process, no actual service details will be provided to the consumer. We have the flexible store orchestration strategy, which is again a rule-based strategy, but you can reference your systems and services by using its name or its metadata. So you can describe your a group of systems by using their metadata. And with this strategy, the orchestration will cooperate with the service registry, and the actual service details will be provided to the consumer. And of course, we have the dynamic service orchestration strategy, which means that the matching providers will be discovered by the orchestration core system on the fly, with cooperating with the service registry, and all the service details will be provided as well to the consumer. So this is pretty much the same as we had in the version 4, but now all these 3 strategies is divided into different systems. You can use the orchestration service in different manners as well. So we have 2 types of orchestration, so to say. There is a pool type of orchestration, which was described also in the previous examples, so that your consumer system consumes the pool operation in order to immediately obtain the matching service instances. So your consumer initiates its orchestration request towards the service orchestration service. And we have a different kind of service orchestration, which is the push type. When a consumer system consumes the subscribe operation in order to receive new orchestration results every time when a higher entity triggers a related orchestration process. So the actual matching service instances are being sent to the consumer without its direct request. There is always a higher entity who decides that a reorchestration should happen now, and it will trigger the orchestration process, and the orchestration results will be sent to the consumer without its direct request. How this push orchestration looks like. I have two use cases. So one, when a higher entity defines the orchestration rules. So this higher entity knows that which consumer should consume the specific service from which provider, and it knows also the service requirements, meaning how the consumer is able to consume a specific service on which security level, via which interface, and so on. So all the important knowledge is on the higher entity. And we have another use case with this push orchestration when your higher entity only defines the orchestration rules. And your consumer itself knows its service requirements. Again, what is the interface? I know what is the security level I can use, and so on. All right. Yeah, so another main focus in the fifth generation of Arrowhead is to provide an advanced translation support. We have had some kind of translation support in version 4, but it was focusing only translating between HTTP and co-op, and there was no data format and data model translation at all, and everything was hard coded into this translation core system. And now it has been decided that all the translation tasks will be outsourced to different providers. And it has the advantage that you can have your own specific protocol and data format and translation providers. So you can develop your own translation, which is translate from XML to JSON, from MQTT to HTTP, for example. The key point here that all these translation providers should or has to implement specific services. When we're talking about protocol translations, they can implement the translation negotiation service and the translation bridge service. So with this way, it will be able to connect to the local cloud and provide its translation service the same ways as the other protocol translation providers are providing their services, no matter that the actual translation happens between protocol A and protocol B, or protocol C and protocol D. And the same is true for the data translation provider. The service is always the same, but under the hood, it can translate between data format and model A to B or C to D. It does not matter. It will be able to provide its service the same way. The orchestration process will integrate this translation bridge building, so to say. So the orchestration will be able to decide that the translation is necessary or not. And if yes, the translation manager will be asked to check or to decide that the translation job can be performed or not, meaning that there are proper protocol and data format providers available in the local cloud or not. And if yes, the service orchestration can initiate a translation job when it's necessary, and the translation manager is able to choose the proper protocol and data format translator, and will be able to send its translation bitch or translation negotiation request to the parties in order to have this translation bitch ready when the consumer gets back its orchestration request. And actually, this consumer will send its service consumption request to this bridge in the way that you can see in this this picture. So so everything starts with the service consumer orchestration request to the service orchestration. The service orchestration will, of course, query the service registry and will see that there is no proper provider who is providing its services on the required via the required interface, but there are other ones who are providing the same service but with different interface. And if the translation is allowed by the consumer, then it will ask the translation manager to discover that this kind of service translation request can be fulfilled or not. It will consult with the service registry, looking for the proper protocol and or data model or data format translator. And if there is proper providers, then the service orchestrator will decide that, okay, now we will build a translation bridge and will instruct the translation manager to init the translation negotiation with the chosen protocol translator and the data translation provider. And the translation negotiation itself means that the translation manager instruct the protocol translation to create an endpoint on the fly for the service consumption. And if there is a data format translation is required, and then this is the data translation provider that you should use for the data translation. And when this bridge is built, then it will report back to the service orchestrator and it will put this information in the service orchestration results, and the consumer can start its service consumption. But instead of connect directly to the provider, it will connect to the protocol translation provider. It will manage the translation between the protocols and between the data models back and forth if it's necessary. This translation support will be released in version 5.1. So this whole thing is still under specification. You can share your thoughts and ideas regarding this topic during the roadmap meetings we have, or just using the GitHub issue, which is linked in this slide, and there you can comment and create suggestions if you would like to. And yeah, as I said, our last but not least, we have this goal that aim that we would like to provide a higher level of user support. So the board has been created this generic system of system description, which is a high level
Hello, my name is Raimund. I'm a colleague of Tamás. He has a storm when he right now, so he can't finish. But this was the last slide. So what he want to said that we has this general system of system documentation on that link that was on the last slide, and the second one we develop a website for the reference implementation as well, and there was the link there for this reference implementation site and for the download link for the test builds. Tamás will send the slides to the mailing list so everyone can find that on an email client and see these things as soon as the storm is calmed, because it caused the blackout for Tamás. So that was the feature presentation. Sorry about this mess. Any questions? Maybe. If there are no questions.
I have two questions actually.
Okay.
So when you have a consumer and you want to consume a certain service provided by another component, do you specify this in very explicit terms and very direct terms, or can you specify this more in, let's say, a semantic way and let the orchestrator actually find, let's say, a corresponding service that can perform that particular task? Like, how does this work? At what level do you specify these requirements?
There are multiple levels actually. The most important one, you have to specify which service want to consume. It's the service definition name. But you can also specify a very large you have a lot of option to filter out different providers. For example, you can specify a version if you want a service has a version as well. So you can specify I want this exact version, not the other ones. You can specify which operations you want to use on that in that service, because in Arrowhead 5 a service is a set of operations basically, and you can describe I just want to read data from this sensor, for example. I don't want to configure this sensor, and this can be important because some consumers can have access rights to read the sensor but not have the proper permissions for configuring. So in that case, if you have no access right for the whole service, you have to specify the operation you want to use. Also, you can add filters to different interfaces. I want to connect to this sensor in HTTP, or I want to connect in MQTT, or any other that the services is provided by different providers. Also, there are service metadata as well, so you can specify metadata requirements. When a provider registers its service into a service registry, he can provide basically a map of data that which we call metadata, that describes that service instance in any details it want. And we get for the orchestrator, you can specify these if you want. Also, you can add preferred providers. I want the consumer service and I prefer this provider if it's available. also there are some orchestration flags which you can use to change the behavior of the orchestration. One is this which called only preferred. In that case, the orchestrator only return orchestration results if it finds something that is a preferred provider. Or you can add the orchestration flag called matchmaking. In that case, the orchestration will return only one result, if any results available, because it will choose one for you. Otherwise, if the matchmaking is false, it returns all the possible candidates. And I think there are more.
Okay, but if you give,
I think the semantic way can be happening if you use the providers and the consumer use this metadata possibility to describe what the service instance is.
Mm-hmm. But still the name needs to match exactly.
The name is necessary. Yeah.
Okay, thank you. And then with this subscription-based orchestration, you have this higher entity. What is this exactly? Is this like a component in the framework, or?
It can be any system, a higher entity has the proper rights. In the Arrowhead 4, there was a system developed by a partner named Plan Description Engine, and that was describes a factory or something like that, and they can dynamically changes the factory which consumer should use which provider, and dynamically choose changing, and then they wanted to the consumer follows these changes. But in Arrowhead 4, it was a very difficult process to achieve that. In this Arrowhead 5, the plan description engine can be a higher entity, and the situation is changed in the factory. They can change the orchestration rules and trigger that something is changed, and the orchestrator will reorchestrate based on the subscription, the consumer subscriptions, and the consumers will automatically receive the change situation, the new providers based on the change situation. That's the idea. But anybody can be a higher entity. It's just based on authorization rights. So if somebody has the authorization rights to call the trigger or the trigger operation of the I don't know what the service name, orchestration management or subscription orchestration management or something like that, then it is a higher entity.
Okay, so the role can also be fulfilled by multiple.
Yeah, it's not a dedicated system. It is just a system with the proper rights.
Okay, and what happens if you trigger this? And so you have a consumer who is consuming, let's say, an old service, but then it's no longer supposed to. But is it then all of a sudden forbidden, or like how do you enforce this?
I don't think you can enforce it, but if the consumer is subscribed to an orchestration, when the trigger is happened, the consumer will receive the new orchestration results. After that, the consumer responsibility to use the new orchestration results and discard the old ones.
Okay, but it could, in
but
theory,
we can't force
it
because this orchestration is we follow this late binding, so the orchestration ends when the consumer receive the orchestration results. It doesn't do anything after that, the orchestration.
Yes, exactly. All right, thank you.
Any other questions? If not, I can't show you the this agenda because I don't have. But if somebody has something that does in the project and wants to share, please share. If not, there will be the next bi-weekly in 2 weeks time, 17th of June, I think, in the same time. And thank you everyone for joining.